quick intro to sinusoid functions. Now, first of all, we're going to talk more and more about what the graph of a sine and a cosine function looks like. But before we get into all that, I want us to just think of generally some characteristics of these wave functions. Essentially, in general, sine functions have some specifics to them. Sinusoid would be kind of all the transformations of a sine function. Okay, so as you know, any function can be transformed by, putting numbers in different places and shifting it around and stretching it out and things like that, and we're going to get into all that. But first, I want us to just think about general, what is a sinusoidal function look like? Now, all of these are examples that are sinusoidal and periodic. So a sinusoidal function will naturally be periodic. Periodic means it is repeating the exact same wave. That's kind of what it is. That's what I'm going to call it. It's repeating that same thing over and over and over again. That is periodic. And it's doing it at a regular interval. It's not doing this and then leveling out and then doing it again. And then it's constant. It's constant at that same interval. It looks like it could fold over itself because it's the same thing over and over and over again. And the fact that it's sinusoidal means that it is a constant wave at the same time. Notice some things that are periodic but are not sinusoidal. Notice how the waves are not the same. I guess I'd say they aren't the same height or depth every time. Maybe the height is always the same, but the minimum is not always the same. Well, the maximums are always going to be the same. The minimums are always going to be the same if it's sinusoidal. Notice here again, we had some minimums that are down here, some minimums that are way down here. The minimums and the maximums are not consistent. So these are periodic. We are still doing that regular interval, repeating what we have, but it's not sinusoidal. Down here, these are neither sinusoidal nor periodic. The heights are all changing, the heights are all crazy, and the period, well, it's not periodic because it's not repeating the exact same thing. So, a period of a sinusoidal function is basically a cycle of the sinusoidal function, a portion of the graph from one point to a point that starts the next repeat. Okay, it's basically how long until it's just going to repeat the same thing again. How long? What is the x value before it's just going to do the exact same thing again? And I like this right here. The easiest way to determine the period is to measure from the top of one crest to the top of the next crest, because we know once we get to the top of that next crest, it's just going to go down and repeat itself. Down and repeat. So that is how we calculate the period. We'll do that in a second. Also, the sinusoidal axis, it's kind of like, because I know a lot of us like to relate things to what we know, it's kind of like an axis of symmetry. But these functions are not going to be, they're not going to be symmetric like this. It's not exactly symmetric, but the sinusoidal axis is kind of, it's what splits, it's the horizontal line that splits our function in half. Basically, it's right there in the middle. And so no, it's not an axis of symmetry. It won't be able to fold this over itself, but there's a clear line that is going to be right smack dab in the middle of our function. And how to find this, we're basically going to find the average of the y value for the max and the y value for the max and the y value for the minimum. We're going to average them together, and it's going to be, if we have x's and y's, it's going to be y equals the average of the heights. The amplitude is going to be the vertical distance from that axis that we were just talking about. okay, is the vertical distance from the sinusoidal axis to the maximum or the minimum, because it's going to be the same, because the axis is right there in the middle, it's going to be the same distance to the top or to the bottom. So let's try all this out here. A period, remember, we can find the period. Easiest way is to go from the top of one crest to the top of the next crest. We want to see how many x values to get to that next one. Well, this right here is at 5, and we're going to 25 to get to that next. So the period, how far to get to that next crest before, because notice we do this down and up, and what are we going to do? We're going to do the down and up again, we're going down and up again. That is the period, and that is 20. The sinusoidal axis, we find the average of our maximum 4, our minimum -2. The average of 4 and -2 is 1. So this would be y equals 1. If I were to draw that line, check it out. That horizontal line at 1, well, isn't that right smack dab in the middle of this? It's not symmetric right here. We can't fold this up, but this is splitting our function in half. Now that we have that value, y equals 1 is our sinusoidal axis. The amplitude is the distance from this to our crest on the top or our crest on the bottom, and either way it's 3 units down or 3 units up. So the amplitude is 3. The y-intercept, where does it intersect the y-axis? We can see right there, the y-intercept's 1. And the range, what are the possible y values we can get out? Well, our lowest is a -2, our greatest is a 4. So this is y values from -2 to 4.